Hello everyone, I am back with a new video. This is in continuation to my first video where I have shared my phone screening round 1 experience. If you have not watched, I have added the link to that video in the description below. You can go and watch that. After clearing the first round, I was asked to provide my availability for second round of phone screening. The phone screening lasted for approximately 45 minutes. It started off with what I know about the physical design flow. I began talking about the flow starting from synthesis, floor planning, placement, clock tree synthesis, routing, physical verification, RC extraction and timing sign-off. Then I was asked, let's say you have a timing report. What information does it provide? I began my answer with the what type of report it is. Basically, if it is a max or mean delay timing report, the type and the number of cells that the path goes through, the drive strength of those cells, the start and end point of each path, slack of the path, delay of each cell in the path, and if the timing has met or violated. Then came some follow-up questions based on my answer. Basically like, what is slack? I answered it's the difference between the required time and the arrival time. Suppose it is the max delay timing report and the slack is negative. How to resolve the timing issue? My response was increasing the drive strength of cells, reducing the logic levels, swapping high threshold voltage cells with standard or low threshold voltage cells, reducing wire length to reduce interconnect delay. Whatever I was answering, I was asked to justify my answer, like how increasing the drive strength of the cells will reduce gate delay, how swapping threshold voltage cells with standard threshold voltage or low threshold voltage cells will reduce delay. So basically whatever you answer, you need to justify it. Coming to the next question, I was given the setup time and hold time of a launch and a capture flop with a combinational block in between, and I was asked to find the maximum frequency of operation. Before answering, I asked what is the clock to queue delay to the interviewer, as the information wasn't present, and I was told to assume it as 0. Here the interviewer was making sure if I am aware of setup and hold equations or not. As you can see, the combinational block delay was not given, so it needs to be found first. From the hold equation we can find the combinational block delay, use it in the setup equation to find the maximum time period and in turn find the maximum frequency. Moving further, I was asked about Cmos power dissipation. Cmos power dissipation is divided into two categories, static power dissipation and dynamic power dissipation. Static power dissipation is the off-state power dissipation, while dynamic power dissipation is on-state power dissipation. Static power dissipation refers to the leakage power dissipation. On the other hand, dynamic power dissipation is further divided into switching power dissipation and short circuit power dissipation. Short circuit power dissipation refers to the timing window in which both the NMOS and PMOS are on for a short period of time, resulting in a direct path between VDD and ground. It happens when the input is transitioning from 0 to 1 or 1 to 0. Switching power dissipation is directly proportional to half alpha C VDD square multiplied by frequency of operation, where alpha refers to the switching activity. Coming to the next question, I was asked what information does the dirt leaf contain? It contains the functionality, leakage power, short circuit power, area and timing information of the cells. Then I was asked some questions related to my work. I was told by the interviewer that the HR would reach out to me for next steps. After a couple of days, I received a call for an on-site interview. I will share the on-site interview experience in the next video. Please do like, share and subscribe to support the channel. Thank you.